There it is. Okay, there. We'll make this work. So this is, what's the title of this one? Graphs of functions, and 1-4. Okay, so it's 1-4. Now, when we graph functions, we have to think about, or we will be asked at least, to think about domain and range. And domain and range is a big part of this lesson, allowing us to recognize what the domain of a function is and what the range of the function is. So domain goes with inputs, range goes with outputs. So if we think of x and y as an equation, the x values are going to be the domain, the y values are going to be the range. And depending upon the type of equation or relationship that we're working with, domain might not be in one situation what it is in another. So for example, if we were talking about car speed, and if car speed, and this is the example that they give in the book, if car speed affects how long it takes to stop, the distance to stop the vehicle, if car speed causes that distance to be different, then car speed is the input. And then the stopping distance, or the skid distance, is the output. So the domain of a function, if we're talking about a car flying down the road and slamming on the brakes and measuring how long it takes to stop, the domain of the function is the speed, and the range is the stopping distance. Now, what kinds of numbers would you use for speed? Miles per hour. But what kinds of counts? What would be the actual numbers? What would be the slowest speed that you could think of? 0. And then if we said that we were going to limit the speed to what the speed limit is on a road, and they'll do that for safety purposes, but then they go beyond. But either way, if we say that we're going to limit ourselves to what the speed limit is, if you go on like most 4-lane highways down in the States, it's 70 miles an hour. So in that case, we might have a domain that goes from 0 to 70. So if it goes from 0 to 70, and then we were thinking of the inputs as x, we could say that x is going to fall between 0 and 70. And it would be all real numbers between 0 and 70, because you could be going any speed, any decimal speed. It's not like a sequence where it's only counting numbers. Speed is continuous from 0 to 70. So if we're going to write this in what they call set builder notation, then we would put this, that's not very good, we put that into the squiggly nice brackets. And then what we do is we come out front, and I want to double check and make sure I'm doing it just so, because I've learned it a slightly different way. I think it does not have, it's not going to have a colon. And actually this is going to be placed out front. So here's what we say. We say the domain of the function involves the variable x, where x is from 0 to 70, includes 0 and includes 70. So you put whatever inequalities you need in there. If it doesn't include 0 in a different function, then you would use a different inequality symbol, of course. So with your graphing calculator, let's plug these into y equals. We've got two different functions here. One of them's for a car, and that's c, the function c. You too. You have a graphing calculator. So you just go right to y equals, and then we're going to put in, the first one is going to be x plus x squared over 20. What's that? Division. So you just type x plus x raised to the second power, and then you have to move over. And then you hit divided by 20.
You have to put that in parentheses then, right?
Yeah, you shouldn't have to put it in parentheses because the division will get done first. So your key sequence is going to be the x, t, theta key, the plus key, and then the x, t, theta key, and then raised to a number 2, and then use your arrow over to the right to get away from the exponent. And then you're going to do the divided by, and then 20, and then hit enter. You did yours as an actual fraction? Yeah, okay. Yeah, if you can do that, great. You're a step beyond me. So this is what I ended up with it looking like. I don't know if you can see these LCD things on here now. But let's do s of x. That's going to be x plus x squared over, say, 12. And this function here, this is for an SUV and this is for a car. So cars stop a little bit quicker than sport utility vehicles, which makes sense. Lower to the ground, they're meant to be driven differently. And we're going to get two different looking graphs. And then what I'd like you to do is I'd like you to go to your window. Do you? Did you just click graph? Yeah. It might be your window sign. Let's see what you got here. Oh. Okay, well, you're good. Yeah, so if you graph it on a standard window, you're going to get things outside of the domain. Okay? Yeah. So if we graph these outside of the standard window, you're going to get things outside the domain. So what we should do is, this is going to be the x. Let's change our domain from 0 to 70 by going to the window. So do the minimum at 0, do the maximum at 70. And then you can do the scale at, I don't know, 10 would be fine. You have tick marks every 10. And then we can see what this is going to become by looking in the book at the top. Way up on the top. Second from the left is window. So do your x minimum and maximum like that. Do your y minimum. Now this is the skid distance. That's going to be 0. Yeah, if you did 500 like in the book, and then do a scale of 100 maybe, and then you'll have something you can look at. So what I'm trying to get you to do here is just to put both these functions in, be able to compare them in an appropriate window. So our domain and our range get to be something that we look at when we set window size. Now we went to 500, which is certainly beyond the range of this function c. So this is the domain of function c. And the question is, what's the range? So in the book, that's the blue colored graph. And then, geez. Is that the blue colored graph?
Yeah.
For ours as well? Okay. Okay, good. That's consistent with the book. That's nice. Okay, so our range we're going to write like this. Y is going to go from 0. So what do you think it goes to when we have a domain of input of 70? What's the top end for the range? What does it appear to be? 300 something? So what we can do now is go to the table. So in the upper left, second graph, that's the table function. If you want, you can scroll down to 70. Or remember, you can do table set and start yourself right at 70. So second window function is table set. And then you can just jump right to 70. And that would probably be a good idea, because for both of these functions, the domain is going to be 0 to 70. And we want to know what the range is. So what is the range for the c of x function? 315, 0 to 315. And then we could also write the domain and the range for s of x as well. When we write domain and range like this, we are assuming that it is all reals. So remember, real numbers are everything that you know of right now. All the rationals, the irrationals, all the positives, all the negatives, the fractions, the decimals. Any way we want to look at it, including 0. Those are the reals. So every number in between, every other number. And we'll get to imaginary soon enough.
Yes.
Yeah, but we don't spend a lot of time on them because they're just imaginary. So in terms of other information you need to know, this is big here. On page 29, there's a breakdown. The reals, let's see if I can do this. If I come over here. Yeah, it's on page 29. So reals get broken down into rationals and irrationals. Do you remember what rationals are? That's okay. Rational numbers are numbers that can be written as a simple fraction. So anything that has a repetend as a decimal number, a repeating fraction may be written as any number that has a repeating decimal may be written as a fraction. You bet. 0.3 repetend is a third. Yeah. And there's lots of fractions that if we do the division, we get a repetend answer. So things that are irrational are going to be things like pi and any of the square roots which are not perfect squares. Like the square root of 2. It doesn't have a repeating component. It's irrational. It cannot be written as a fraction. So then there's integers and non-integers. There's negatives and non-negatives, naturals and 0. Naturals are like counting numbers 1, 2, 3, etc. They do not include 0. So set builder notation for writing your domain and your range. Look and see if there's anything else I want to make sure to tell you about. That's about it. You remember how to use the trace feature? Yeah, when you guys had calculators in algebra, they weren't these, were they? They were the old ones. So these are kind of sweet. When you're looking at your graph, if you hit the trace key, which is in the top right next to graph, it will show you on the bottom of your screen the approximate ordered pair of where you are moving your cursor. On the top of the screen, it'll tell you which plot that is if you're plotting things out of L1 and L2. So you move left and right, you can see that the ordered pairs on the bottom are going to change. If you use your up and down arrow, you can jump back and forth between functions. And so you can compare similar inputs and find out what their outputs are by jumping up and down between different functions without having to go right to the table. So that's it. Then it's your homework.